Hello, welcome to Millionlights. My name is Pratik Shah. I'm an assistant professor in Dr. D.Y. Patil School of Engineering. In the previous module, we had discussed about potentiometers, bar graph displays, and few of the basic concepts regarding programming. In this module, we'll see the programming part further. We'll see for loop and switch case condition. We'll take few of the examples and based on them, we'll understand how for loop works and switch condition is used. We'll start with for loops. Loop is used to execute few sentences repeatedly. For that we have three types of loops: for loop, while loop and do while loop. In that, for loop is used maximum times for the programming. So we'll explore the for loop. For loop is used to repeat a block of statements enclosed in a curly braces. An increment counter is usually used to increment and terminate the loop. The for statement is useful for any repetitive operation and is often used in combination with arrays to operate on collections of data pins. The syntax for loop is this. First we have a for statement. In that we take a round bracket. In there we write three things. One is initialization, second one is condition checking, and third one is increment or decrement. In for loop we can write the statements which we want to execute repeatedly. Now for loop was used in bar graph display program, the shorter version, in which pin mode was done using for loop. So their pin mode and the output pin and then output, the same, it was same, just the pin numbers were changing, like 2 3 4 5 6 2 to 11, that was only changing, the rest all things were same. So we used for loops, one statement was used, and instead of writing the pin number we used an array, and the value of array was changed from 2 to 11. So just one statement and a for loop that is used to repeatedly execute the same statement. So instead of writing pin modes 10 times, we are using for loops. Now for loop, as we discussed earlier, syntax is quite simple. We have for loop. For doing any loop or executing repeated number of times a few statements, we need three things. One is to initialize. That means we need a variable that will tell how many times we have to execute the statements. Therefore we have to first initialize the variable. Then to execute that number of statements we need to check the condition. Suppose x is less than 10, x is greater than 10, or whatever, we have to check the conditions, and depending upon that we build the logic to execute those statements multiple number of times. And the third part is to increment or decrement the variable. If we do not increment or decrement the variable, the problem will be that the loop will be infinite and the statement will be executed continuously. So suppose I want to execute a statement or block of statement 10 times, I need to first initialize a variable to a particular value, then I need to write a condition, and then the variable should be incremented or decremented based on the condition. Then and then only the sentence or the statements will be executed 10 times. Now this is the syntax of for loop, we have discussed it. Now we'll take an example. Now here you can see this is an example which is used to print the value of I, and the value of I is printed 10 times. Now here I for is written, and inside the round brackets we are writing int I is equals to 0. That is to declare a variable named as I, and that is initialized to 0, and we have to write condition checking after that. Condition checking I is less than 10. So as long as the value of I is less than 10, we will execute this, and then we are giving it an increment operator. The increment operator is I plus plus. I plus plus will increment the value of I by 1. So initially the value of I will be 0, and then we check the condition that I is less than 10. 0 is always less than 10 definitely, so we go inside the for loop, and whatever is written inside the for loop, that is executed. The thing that we have written here is serial.println, and inside ln I have written I. Therefore I am printing the value of I, that is 0. So first of all I am printing 0, I am giving a delay of 300 milliseconds. Done. Then after when we get the closing bracket of for loop, we once again go to the condition checking. Now when we go to condition checking of for loop, before that we use the increment operator. That means the value of I is incremented by 1. Now when we go up to check the value or they check the condition, the value of I is incremented by 1, so value of I becomes 1. Now 1 is compared with 10, 1 is less than 10, definitely condition is true, and we go inside the loop. Now inside the loop, what we are doing, we are printing the value of I. There is a delay of 300 milliseconds, so we print the value of I. The value of I is 1, so we print 1, and then we take a delay of 300 milliseconds and we once again go up. Now when we go up, we increment the value of I becomes 2. Now 2 is less than 10, true, we print 2. Then once again we go up, while going up the value of I becomes 3. It will work for 3, 4, 5, 6, 7, 8, 9. 9 is also less than 10, so it will print for 9. Then after that, when we go up, the value becomes 10. Now the value of I is 10 and 10 is less than 10, this condition is false, because 10 is never equals to less than 10. 10 and 10 are same. So the condition is false, we do not go inside the bracket and the for loop is terminated, and the statements after for loop are executed sequentially. So this is how for loop works. So for that, we have to make a logic of initialization, condition checking and increment decrement operator in such a way that this works properly. Now the value of I will be varied from 0 to 9. When the value becomes 10, it won't work. So how many times this loop is executed? This loop is executed 10 times. For 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you start from 0 and less than 10 if you write, then the loop is executed for 10 times. Now suppose if I say the value of I is equals to 1 and I is less than equals to 10, if I write like this program will not work for 10 times, this program will work only for 9 times. So initialization and condition checking, they have to be taken care of. Okay, now what we'll do is we'll write this code onto the Arduino IDE, compile the code, upload it onto Arduino, and we'll see what the result is. Now we'll do one simple experiment. In this experiment, I'll be using only Arduino and this USB cable. No other hardware is required. This experiment is to explore how for loop works. The code is available on the Arduino IDE. I already typed the code. This code is the same one that we had seen in the previous slides. Now void setup is quite simple. We are just starting serial communication with the baud rate of 9600, and in void loop we have got for loop, and for loop, in that I am declaring integer variable whose value is I, that is I initialized to 0, and till it is less than 10 I am incrementing it and I am printing the value. So now I'll compile the code, and till the time it is getting compiled I'll make the connections. Connections are nothing but just USB cable and Arduino board. Okay, so the code is perfectly alright. Now I'll upload the code onto Arduino board. Okay, so here what is happening, my Arduino is using for loop. It has initialized a variable, it is assigning the values from 0 to 9, and those values are transferred from Arduino to PC one by one with the help of serial communication. So let us open the serial monitor and see the output. Now I can see the output is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after 9 once again 0, 1, 2, 3 is repeated till 9. So the output is nothing but values from 0 to 9, and after that they are repeating, because inside for loop we have written what, serial.println and the value of I, and the value of I is going from 0 to 9. The value of I goes to 10, but when it goes to 10 we do not enter for loop. So this is what actually happens. Now we'll do few of the changes and we'll see what the output is. Now suppose instead of starting the value of I from 0, I'll start it from 1 and I'll upload the code. Now you can see from 0 to 9 it was printing in the previous case, now it will print from 1 to 9 and then it will go to 1 back. That means only 9 times the loop is executing, it is not executing 10 times, because we are starting from 1 and till I is less than 10 we are executing it. Now if you want this to execute 10 times, you have to add one more statement, that is I is less than or equals to 10. Now when we add this and we execute this, then the output is something different. Okay, so this is uploaded. Now we'll see the output. Output is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we are displaying till 10 because I is less than or equals to 10. So when the value of I is equals to 10, then also the condition is true and then also we are printing it. So if you want to print value from 1 to 10, the condition checking will be less than equals to 10. And if you are starting from 0, the condition will be I less than 10. So this is how we can use for loops for various other things. Now in the next part we'll see a circuit, we'll make a circuit and we'll write a code which will illustrate the use of for loop more further. Now we'll do one simple experiment which will illustrate the power of for loop. In this experiment we'll be using Arduino, breadboard, we'll be using 6 LEDs, USB cable and few jumper wires. Now the aim of this experiment is to light these 6 LEDs. Now these 6 LEDs will be connected to digital pins of Arduino and one by one we'll be switching all these LEDs. So first we'll switch on the first LED, then we'll switch it off. The LED will be switched on for 100 milliseconds. So it will be on, off, then second one, third one, fourth one, fifth one, sixth one. So at a time only one LED will be on. Then the process is repeated in the reverse order. The sixth one will be on, then fifth, fourth, third, second, first. If you recall, the same kind of experiment was performed in earlier modules, but the code was quite lengthy. Because if you want to switch first LED on, then I have to write digital write to high, then I have to write a delay, then I have to switch it off. Then for switching the second LED, same code, third LED. So 6 LEDs means 3 into 6, 18 lines of code. And if I want to come back in the reverse direction, still more 18 line of code. So instead of that, in this experiment, we'll be using for loop, and inside the for loop 3 sentences we have to write. So just 3 sentences and a for loop is equivalent to the 18 line code that we had in the previous module. So first let us see how the schematic is. This is how the circuit diagram is. We are using 6 LEDs. These 6 LEDs will be connected to Arduino board. Pin number 2 is connected to first LED, pin number 3 to the second LED. So from pin number 2 to pin number 7 we are connecting them to LED. You can use a 220 ohm resistor if you want. I am not using it because it will simplify the connections. And then all the cathodes are clubbed together and they are connected to ground. Pin number 0 and 1 is not used because they are for serial communication, transmission and reception. So the circuit is quite simple, just connect LEDs to the pins and then we'll see the code and upload it. Now first let's start building the circuit. First we'll take LEDs. The positive terminal of the LED is connected on this side and the negative, that is cathode, is connected to the fourth panel, that is vertical lens. Okay, so here same thing. Okay, so I have connected all the 6 LEDs. Okay, now I have to connect them to Arduino. Okay, first this goes to pin number 2, this goes to pin number 3, pin number 4, pin number 5. Make sure that you are connecting in the same slot. Sometimes if we do not connect them, then the circuit is not completed and the LED will not glow. Pin number 6, finally pin number 7. Okay, so all the anodes are connected. Now we have to connect the common terminal cathode to the ground. So it is connected to ground, that is pin number, that is above pin number, which is above pin number 13. Okay, now we can connect it with the PC. Okay, now we'll see the programming part and the output. This is the program which we are going to implement. Uh, First part is void setup. In void setup, we have got 6 LEDs and we have to initialize them as output. So instead of writing pin mode 2 output, pin mode 3 output, we are using for loop. So now what we have done, for, that is starting of for loop, and in that we have written int this pin. So this pin is the name of the variable and it is an integer and it is assigned or initialized to a value 2. So for loop start from 2 and the condition is this pin less than 8. So till the value of this variable is less than 8, we are executing this condition. Then the increment decrement operator is this pin plus plus. That means we are taking a variable that is initialized to a value 2 and the condition is still till the value of the variable is less than 8, do this experiment or do this loop, and the value of this variable is incremented by 1. So inside this for loop, what we are doing, pin mode this pin out. That means pin mode is for telling which pin is used and which mode. Inside that I am writing this pin. This pin, the value of this pin is initially 2. So it is as good as writing pin mode 2 output. Then we go up, the value becomes 3. So it becomes pin mode 3 output, 4 output, 5 output, 6 output. So till all these initializations. So instead of using 6 pin modes, I am just using a for loop and a pin mode. So instead of 6 instructions, 2 instructions are sufficient. Now we will see the for loop. Now in main programming, that is void loop, what I want to do is I want to start one LED, that is switch on one LED, then second one, then third one, then fourth one by one. So what I want to do is digital write to high, then a delay of 100 millisecond, then digital write to low. So this is for first LED, then second, then third, then fourth. So instead of that, I am using the same formula, that is I am using for loop, then I am declaring the variable that is this pin, and this pin is less than 8, till the value of this pin is less than 8, I am incrementing the variable. And inside that I am writing digital write this pin high. So instead of writing digital write to high, I am writing digital write this pin high. Now this pin is a variable, so the value of variable is initially 2. So it is as good as writing digital write to high, then a delay, then digital write to low. So instead of writing 6 digital writes, delay and once again digital write, I am just writing one time. So it is just requiring 3 lines instead of those 18 lines. Then we want to do it in the reverse direction. That means I want to switch on the the sixth LED. So for that purpose, I am starting the loop, but the loop is started in the reverse direction. As I said earlier, you can either increment or decrement. So here I am doing the decrement. Why? Because I want to start with the sixth LED, then fifth, then fourth, third, second, and first. So here int this pin is equals to 7. So the variable this pin is initialized to 7, and till the value of this variable is greater than or equals to 2. So till it is equals to 2, I am coming in the reverse direction. So this pin is decremented. Okay. So inside that what I am doing, digital write this pin high. So the 7th pin is high, that means the 6th LED will be high. Then a delay, then it is low. Then the value of the variable will be decremented, so it becomes 6. So the 5th LED is on, off. Same thing comes in reverse order. And this is written inside void loop, so the same thing is continued. So we go up, come down, and same thing is repeated as long as power supply is given to Arduino. Now we'll write this code into Arduino IDE, compile it, upload it, and we'll see the output. Now let's upload the code and see the output. I have already written the code in the Arduino IDE. Now we can upload it. Okay, so the code is uploaded. Now you can see the output. First LED is on, then it goes off, then second, then third, then fourth, fifth, sixth, and same in the reverse order. Now in this experiment, if you see that only one LED is on at a time. Okay, so the delay is 100 milliseconds. Now what if I reduce the delay? If I make the delay as 5 milliseconds, then what will be the output? We'll see that. But one thing I would like to tell you is that only one LED is on at any given particular time. In this code, just one change I'll do is I'll reduce the delay from 100 milliseconds to 5 milliseconds, and we'll see what change happens in the output. Okay, so the delay is changed from 100 to 5. Now we'll upload that. Okay, so here it is happening quite fast. It, you might feel that it is as if that all the LEDs are on, but they are blinking at a very high speed. So instead of this, now what I'll do is I'll reduce the delay more further. I'll make it 3. I'll change the delay from I'll make it 2. Okay, so I'll make it 2 and I'll upload it. Okay, now you will feel that all the LEDs are on. Why is this? This is because the LED is being switched on and off at a rate of more than 20 times per second. That means 20 times, more than 20 times the LED is on and off in a second. So due to this, what is happening, we are not able to, our human eye cannot detect any change in the vision or a scene if it is of more than 20 frames per second. So anything that if you are shown more than 20 images in a second, it becomes an video. So normally our video has 30 frames per second. What is video? Video is nothing but stream of images shown one by one. So if you switch any LED on and off more than 20 times in a second, you will feel that it is on only. So this is called as persistence of human eye effect, and that is maximum times used, and it is very hard to debug. So if you have some mains leakage in 555 or any some other circuits, then due to that your LED is continuously on. So even though you are making an astable multivibrator, the output is always high. So that is due to the fact of the leakage, and we have to take care of that. Now we'll see the switch case condition. Now switch case is used in parallel with if else. So if you want to use else if ladder, then instead of that you can also use switch case. Switch case is easy to understand, and debugging of program becomes easy, and understanding of program also becomes easy. Now in switch case, this is the syntax of switch case. First of all, we need to have a variable, and depending upon the value of that variable, we can use the switch case. So switch is the keyword that is used for this. Inside switch we use round brackets, and in that the name of the variable is written. So here we are taking the name of the variable as var. So if the value of var is 1, then the case 1 is executed. If the value of var is 2, then the case 2 is executed. If the value of var is 3, then the third case is executed, and so on and so forth. Depending upon the number of cases or number of values, you can write as many cases as you want. There is also one provision of default case. So if none of the case match, then we can execute the default case. Now in this syntax, one thing that we need to write definitely is the break statement. So after each and every case, we have to write the break statement. So when we find the break statement, we get out of this switch case. If we do not write the break statement, so whenever, if suppose case 2 is true, if you do not write break after that, then case 2 will be implemented, 3, 4, 5, each and every case will be implemented unless and until we do not find the break statement. So switch case is used in lot of places, and it makes programming quite easy. Now we will in this experiment or in the next experiment, what we are going to do is we are going to connect 5 LEDs. We are going to collect 5 LEDs to Arduino board, and based on the key that is fetched from the keyboard of the PC, we are going to switch them on. So here we have serial communication, as well as we will be seeing how switch case is used and how properly the things can be done. So the input here will be from our keyboard, that is laptop. Any key can be pressed, and depending upon that key we'll have 5 LEDs that will be glowing. So what we'll do is we'll select 5 alphabets, that is A, B, C, D, E. So if I press A, then the first LED will glow, B then second, C third, D fourth, E fifth. Now instead of these 5, any of the other button is pressed, then all the LEDs should go low. So all the LED will be off if any one of the alphabet except them is pressed. The circuit diagram of this is quite simple. We just are connecting 5 LEDs to pin number 2, 3, 4, 5, 6. So we are connecting 5 LEDs through 220 ohm resistor. If you want to skip the resistor part, you can skip it. So the circuit is quite simple. All the anodes are connected to the Arduino board, and cathodes are connected together, and they are given to ground. So this is how the circuit is. Now we'll actually build the circuit, then we'll understand the code, and then we'll see the output. Now let's start building the circuit. For making this circuit, we'll require Arduino board, breadboard, 5 LEDs, USB cable, and 6 jumper wires. First we'll start with connecting these LEDs on the breadboard. The anode is connected on the third section, and the cathode is connected on the fourth section, that is vertically connected, so that we can make common ground. So first LED is connected, second, third, fourth, and the fifth. So 5 LEDs are connected on breadboard. Now we have to connect them to Arduino. The first LED is connected to pin number 2. Second is connected to pin number 3. Third is connected to pin number 4. Pin number 5. This is connected to pin number 6. Now the cathode is connected to ground, that is pin number 13. 8, 9, 10, 11, 12. No, not 13, the pin that is above 13. Okay. So with this our circuit is complete. Now we have to just connect this with the help of USB cable. To the PC. Okay. Now we'll discuss about the code and the output. Okay, now let's see the programming part. The logic is we are connecting 5 LEDs from pin number 2 to 6. Now we have to switch them on depending upon the alphabet or the keyboard key that is pressed. So for this we require serial communication. Along with that we are using switch case to control these LEDs. Now let us see the void setup part. In void setup part, the first thing will be serial.begin 9600, because we need to do serial communication, because PC is going to communicate with Arduino board, and Arduino board will control these LEDs. Now we have to do pin mode, that is we have to initialize from pin number 2 to 6. Therefore instead of using 6 pin modes, or sorry 5 pin modes, what we are doing, we are using a for loop, and with that for loop we'll start with the initialization as 2, until less than 7 we can do it. So just 2 instructions are sufficient. Then we can start with void loop. Now inside void loop the first thing will be serial communication. Therefore we have to check if serial.available is greater than 0, because if serial.available is greater than 0 means some data is transmitted from PC to the Arduino. So whenever the data is transmitted, we have to grab it and we have to store it in some character variable. Therefore I am declaring an character variable named as in byte. So char in byte, that is equals to serial.read. So we are reading that character and we are storing in the variable called as in byte. Now based on the value of in byte, I have to take the decision. So if the value of in byte is A, then I have to switch on the second pin, that is digital write to high, then and I have to break, that is, this is the first case. If the value is B, then 3 should be high. If the value is 4, then value is C, then the 4 should be high. So therefore we have declared the variable called as in byte, and in that we are storing the keyboard key that is pressed. Okay, now switch statement is used, and in that we are writing the name of the variable based on which the cases will be made, and the name of the variable is in byte. Okay, now case A. Case A is the first case. In that case we are using digital write to high. That means what? If A is pressed, then switch on the first LED and break. So we are writing this break because whenever the first condition is true, we want to break out of the switch case and we don't want to proceed further. If it is B, then we go to case B, and at that time the third pin is high. If the keyboard button pressed is C, then the fourth pin will be high. If it is D, then fifth pin. If it is E, then sixth pin. And if none of these pins, none of A to E is pressed, then some other key will be pressed, and that will be considered in default case. And for default case, we are switching all the LEDs low. We are switching all the LEDs low. Therefore I am using a for loop that starts from 2 till less than 7, that is 2 to 6, and we are writing digital write this pin low. So from digital write 2 to 6 will be set to low. So this is the programming part. Now we have to write this code into Arduino IDE, upload it, and then we have to see the results. Now we'll upload the code onto Arduino board and we'll see the output. I have already written the code on the Arduino IDE to save some time. Now I'll upload it. The code is getting uploaded. Okay. Yes, the code is uploaded now. Now we can see the output. First, for that I have to start this serial monitor. Okay. Now I'll press A. The first LED is on. Now I'll press B. The second one is on. Now I'll press C. Third one is on. D. Then E. Now if I press any other key, suppose I am pressing T, then all the LEDs will be off because it becomes a default case, and in default case we have switched all the LEDs as off. Now without the sequence, I'll go randomly. I'll press first C, then I'll press E, then I'll press A, and then I'll press Z. Now Z is a default case because it is not defined, we have not made any cases of it, so it will switch off all the LEDs. So in this way we can make as many cases as we want, and we can control any device with the help of PC. This makes programming simple to understand, and the code, the lines of the code are also reduced. Same thing can be used in robotics. We can use 4 switches and they can be connected to digital pins, and we can use switch case, and based on that, due to the press of mechanical switch, we can connect it, and based on that we can move a robot forward, backward, left or right. So instead of controlling your robot from PC, you can connect or use 4 mechanical switches, connect them to the digital pins, and you can use this switch case condition, and with the help of that you can control your robot. The switch case condition can be used in a lot of places. Wherever you are using else if ladder, you can replace it by switch case, and that is very easy or simple to do. So menu driven programs and all these things can be done using switch case. Hope you liked the video. If you have any queries, you can find us on Facebook by the name Millionlights, or even on Twitter. You can visit our website www.millionlights.org for more such interesting courses. Thank you.